We have just seen how to create streams. Now we'll learn how to end streams. I'll cover terminal operations in the Stream API, which are used to close the stream and produce a result. Terminal operations are crucial for completing the stream pipeline, as they trigger the execution of the stream. Let's move over to IntelliJ and see some common terminal operations in action. So here I have already in my comments which I'm going to show you, and this is a lot, but I will go over them, so don't worry too much. Alright, so in my comments I have all the terminal operations that I want to show you. There are quite a bit of them. And I'm going to do this using the names stream. As I already mentioned, I can only use a stream once, so I need to recreate it a few times. So let's start with the for each. The for each is going to do something for every element in the stream. It's not really producing a result, it's just doing something. So let's go ahead and say namestream dot for each. And then you can see that for each expects a consumer. And we know how to implement consumers. They take something and return nothing. So let's go ahead and implement this with a method reference. And I'm going to do a very simple one, just a print line. There we go. So this is simply going to print all the elements in the stream. Let me show you. There we have them, all the elements in the stream. Let me show you count. Count is going to return the number of elements in the stream. Before I'm really going to show you count, I actually want to show you what you cannot do. And that's using namestream again, because there's been a terminal operation on it already. So if I say count over here, and I then run the play button, we'll get the exception I was talking about. It's the illegal state exception. And has a very clear message. Stream has already been operated upon or closed. So we need to create a new stream. Well, not to worry, we can do that. I just go ahead and say names.stream and then do a count. So this count is actually going to return a long, as you can see here. And I want to store the result in this long number of items. There we go. This is going to store 3 in number of items, because the stream has 3 elements. And then we have min and max. They're going to return the minimum and the maximum element. In this case, the minimum and maximum are based on the alphabet. So let's go ahead and go string min equals names.stream. And as you can see, I can pass in a comparator. And this comparator is needed for it to figure out how to determine the min and max. So let's go ahead and implement the comparator. So the comparator is a special method that's taking 2 elements and then returning an integer. That's going to determine which one is bigger. So I'm going to be lazy. I'm going to specify S1 and S2, the first value and the second value. And then in here, I'm just going to say S1 compare to ignore case S2. So this is actually a very valid red squiggly. It says required type is string. As I said, I would expect a string. But it says, no, what I'm returning is an optional. And we haven't seen optional yet. Optional means that it may or may not actually return a result. Because if this stream is empty, there's not going to be a result and it cannot store this in the string. So instead of having the string, I'm going to make this an optional of type string, like this. Just think of this as some sort of post box, and there may be some post in there, in this case a string, and also may not be some post in there. And in order to get this value out, we need to do the .get. If it's not there, this might actually throw an exception, but it's there, so we don't need to worry about this. So let's go ahead and run this so we can see the result. Please mind, I did not print the number of items because it's a bit straightforward. And as you can see, the minimum here is Mandarin, since that comes first alphabetically. And max, it works in the very same way. In this case, it would print walnut since that's the last one alphabetically. I'm not going to show it. And then we have all match, any match, and non-match. And these are actually very, very similar. So all match is going to check if all the elements in the string match a given predicate. So let's go ahead and say here, optional Boolean. Let's just call this all match. Or let's say bigger than 5. And then in here, I'm again going to create a new stream. And I'm going to call the all match function. And now I need to provide it with a predicate. And remember the predicate, it takes an input element and then it returns a true or false. So let's go ahead and say s becomes s.length bigger than 5. And this gives me red squigglies because the return types, they do not match. It's simply going to provide me with a boolean. And that's just because my mind was with the optional still. This is just going to give a boolean, whether all of them match or not. Please mind that if you do an all match and you have an infinite stream, your code will very likely not finish ever because it won't know if all of them match. If the stream is infinitely long, it will have to keep on checking. Oh, and let's actually print the all bigger than 5. And there we go. Before I'm going to run this, I'm also going to implement the any match and non-match. These are very, very similar. So I'm going to be copying this code for the any match. So what the any match is going to do is just going to check if any of them is bigger than 5. And as soon as the first one is bigger than 5, it can conclude, aha, one of them is bigger than 5. The value is true, I will complete. So how many elements this will evaluate depends on whether a match is found or not. And let's say we have an infinite stream. This may or may not run forever. If it finds a match, it will stop. But if it doesn't find a match, it will just run forever. So if you're doing something that's not going to find a match, it might actually be stuck forever. But if it does find a match, it will stop for an infinite stream. So that's an important thing to take care of. And then we have the non-match, which pretty much does the opposite. It's going to check if none of them match. So as soon as one of them matches, the non-match is false. So in this case, it will come across the first element and already conclude that none of them are bigger than 5. Let's actually also update the methods here, otherwise it's not going to work. So there we have it. So I implemented 3 of them, all bigger than 5, any bigger than 5, and none bigger than 5. So all and any should be true and none should be false. Let's run this code and see the results. And as you can see, it prints what we expected. Okay, 2 more. We have collect and reduce. Again, they're a bit similar, but let's treat these separately because they're very important and a little bit complicated. So collect is going to transform the stream into a different data structure, such as a list, a set, or a map. This is a very, very common thing to do. So let's again create a stream. Well, actually, let's first specify the list that we want to create. Let's call it names list. Now we're going to say names.stream.collect. And then you can see we can do collectors to list. And this is going to store a list of strings in the names list based on the elements in the stream. So there's actually a new way to do this. And it's actually a little bit nicer, so I want to show you. But you'll still come across the old way a lot. And this new way is quite new, so you might not have the option to see this in your code base just yet. And that's the to a list. How lovely is this syntax compared to the other one? So this is available when you use anything after Java 16. Alright, and then we have reduce. And reduce applies a binary operator to the elements in the string, reducing them to a single value. So what I'm going to do, I'm going to create an optional string, because there may not be any strings in there. Total string. There we go. And here I'm going to say names.stream. And I'm going to say reduce. Then I need to specify my binary operator, but I'm just going to go for the string concat. So that's going to concat all of them together. And then I want to print the result. And again, I need to do a get because it's an optional. And if there would be no value, that would be a problem. But I'm quite sure there will be values because I hard-coded them myself. And there we go. We have the total result at the very bottom, which is all the names of the rabbits concatenated. Great. So this is all really great, and we've seen some examples of terminal operations, and we should have a better understanding of how to complete the stream pipeline and produce a result. But in the next video, it's going to be really fun, because we're going to dive into the intermediate operations, and we can use this to modify and filter the elements in the stream before we call the terminal operation.